The first step in our demo is to create an extra table in our schema. And I'm just going to zoom out real quick. What we're going to do is just create an extra table, const, and the demo that I decided to go with is just a incrementer and decrementer. So in this PG table, we're going to call it count. And inside of this count, we're going to have an ID, text, ID, primary key, as every table should have. Then we're going to have the actual count, which will be of type integer. Make sure that you grab that from PG core. And we're going to call this one count, not null. Require it to have some form of a value. And then we're going to have user ID. So to connect this count to a particular user, we can just copy this from what we had before. This part here, go back down. Text of user ID not null references to the user table's ID value here. And when we delete the user from our database, then it's going to cascade and then also delete this count. Great. Once we've locked in our schema, now we can do npx drizzle kit generate. Then after that, we can do npx drizzle kit push to send in our updates. Our changes have been applied. We're all set there. We can switch over to our Neon console, hit refresh real quick, and see that our count table has been added with all of the columns that we have identified: ID, count, and user ID. Great. We can now move on to creating a router that will hold all the procedures and allow for us to create a count object. Entry, we can delete it, we can update it by incrementing or decrementing the integer value in the count column. All of that stuff we can do within procedures. So switching back over to the code, we can start the work on our router by going into our tRPC folder, then to servers, then to routers, and creating a new file here, count.ts. Now what we're going to do is use some of the same code that we used over here in the app router. So we're just going to copy this bit here and then paste it into our count. We're going to rename app router to count router. So now we have the basis for our router. First procedure we're going to make is the create count procedure. And we've got to look at our index.ts to make a choice about which procedure we're going to use. We have two of them that we've created here. A base procedure that we can use for unauthorized users, and a protected procedure, which we have an authorization check here. When we create a procedure, we have a decision to make. Do we make it a base procedure, or do we make it a protected procedure? Does authorization matter to us? Do we want someone to be a user before they can create an account, for instance? Or can everyone do it? That's the decision we're going to have to make whenever we create one of our procedures. So back over to count. When we look at create count, since count requires, if we look at our schema, a user ID, then we need for someone to be authenticated. That way we can then get a user ID from them and apply it to the count entry that we create. So going back to the count here, we've got to use the protected procedure. In this case, since we're making a modification to the database by adding a new entry to a table, this will be a mutation. In our mutation here, we're going to return an asynchronous function. And as a parameter, we're going to have context. We're going to provide to our mutation an asynchronous function, which has one parameter, our context. And let's plan out what goes inside of our procedure here. For our first step, we should check if a count already exists for our user. I think that it would be best to have, just for the sake of this demo and for the sake of simplicity, one count per user. So if a count already exists, then we shouldn't allow the user to create another count. So check if a count exists for the current user. Great. Then if one exists, throw an error. If it doesn't, then create one. So we have our if condition and then our else condition here. So we've got 3 steps. Let's implement it. So to check if a count exists, we're going to do const existing count is equal to await context.db.query, querying count, the count table. We're going to find the first one, where we're going to use a function taken from drizzle ORM equal. So if count, which we're going to grab from @/db schema, this one here, dot user ID matches, and since we in our protected procedure here return an instance of the user here, context.user.id. So we're going to go through all the tables, and for the first one that we find where there's a match between a user ID and the current user that signed in's ID, then we're going to grab that and put it inside of this existing count variable. Then we're going to do this if condition, if existing count. Then we're going to throw new tRPC error. And tRPC error takes in a code, which we can choose one. I think the one that probably matches is internal server error message. We can elaborate on this and say count already exists for current user. Great. And then if it doesn't, then create one. So what we're going to do is just actually let it fall through. So with this throwing, then it's not going to go through to the next part. So this is in the existing count does not exist world. Then we're going to await ctx.db.insert count. And we're going to pass in to our values here a couple of things. But first thing, for our ID, we're going to need some form of identifier to add in here. Unique identifier. So we can have many options. I think the one that I'm going to use is UUID. It's the simplest one to install. So npm I UUID -- force. So I know there are many different unique IDs that people want to use. Nano ID is another one. People have been talking about a lot of the different ones in the discourse. If you want to use a different identifier, it's totally fine. They should all work the same. So I'm going to do UUID here and install it. Then next, I usually like to create a little helper export for me. So the export for UUID isn't very clean. So what I'm going to do here is import v4 as UUID from UUID. So usually you'd have to import that every single time along the top. There's not a clean import. So we're going to do export UUID here. And so that makes a clean export for us. So in this ID here, if I just need my UUID, I can choose @/lib UUID right here and have a clean import. So let's just clean up some of our different imports here, separate them out. Great. Cool. So we have UUID, then we have count, which if we're creating the first one, we can either start it at 0 or 1. I'll just start it at 1. And for the user ID, we're going to provide ctx.user.id. And UUID needs to be a function call. Great. So that's basically our create count here. we go through and we check to see if a count exists for the current user. If one already exists, then we throw an error. If it doesn't exist, then we just create one. Wonderful. Moving on to the next one, we're just going to go in ABC order through our CRUD operations here. We're going to delete next, and deleting a count probably should be a protected procedure. We don't want anybody unauthorized deleting someone else's count. So it makes sense for it to also be a protected procedure. Mutation, async, just like the top one there, provide our context value here. So let's plan out this procedure here. First, check if a count exists for the current user, right? So we can do the exact same thing as we have up here. So that's already step one. The opposite of this one, so if one doesn't exist, then we throw an error. So all we need to do for this one is if not existing count, throw new error, and then just say no count exists for this user, so nothing to delete. And then if we fall through, that means a count does exist, so we're going to await ctx.db.delete count where equals count.user ID context.user.id. So we're deleting the count that has a user ID that belongs to the user that's being authorized here. Great. Moving on to the next one. We'll do our getter procedure next. So just for the sake of this tutorial, I mean, you probably don't want a unauthorized user to get someone else's count, but just for the sake of being able to demo a few things, I'll just make it public. So get count, and this will be a base procedure instead. And this is going to be a query here. So query is going to take in an async function, just like our mutation here. We're going to provide our context and then do some things. But first, when we're getting our count here, well, since we don't have access to this user, then like in our protected procedure, that we need to have some way of indicating which count we want. So usually, since in this protected procedure we have a user and we have a user ID, we can just find any count based off of the user ID. But in this case, since we don't have any user IDs, then we're going to need some way to search for a count that we want. So one of the ways that we can do that is to provide an input here. And before, you might have remembered that we installed Zod. So this would be the place for us to provide a schema for our input. So it's not the same schema that we provided here in schema.ts. We're providing a schema of what a user needs to input to this get count procedure in order to get a proper query. So we're going to do Z to grab from Zod, object, and then we need to specify our input here. And in this case, we're just going to look for count ID, which will be of type z.string. And you can provide some additional information here. You know, if it's an optional value, which this is not, but just in case, you know, in the future you might need it. You have optional, you have min for minimum length, you have max length, you have many ways to modify. It's one of the powers of Zod. You can create these structured types to force the user to provide inputs that you want to your API. Otherwise, it's going to error out. So in this case, we just need the z.string. Unlike in schema, where not null is to specify that something's not optional, in Zod instead, if something's optional, you just say that it's optional. Otherwise, if you don't say anything, then it's going to be counted as required. So now that we have an input here, alongside our context value, we're also going to grab input, which is just an object that has our schema here. So let's plan what goes inside of this procedure. First, we just perform the query. So in this case, query the database to find the count, which has the same count ID. If a count with that ID exists, return it. And if no count exists, we're going to put this before the return here. If no count exists, then throw in error. Okay, so let's grab the count first. So existing count. We're going to do a similar thing to this. So let's grab that. But instead of the user ID, because that does not exist, we're going to grab, and you can do this in two ways. One is you can extract it out by getting count ID from input here, and then using count ID here, right? And then this would be ID. And that's how you would search it. Or you could remove that and do input dot count ID. Both are equivalent. One has an extra statement that you have to write. When inputs get a little bit wild, sometimes you might want to extract all of them, but it's up to you. Personal preference. Either one works. I'll just leave it this particular way. So next, we're going to do if not existing count, throw new error, and, whoops, tRPC error. And let's see if we have one. No count exists. Yeah, so probably something like this. So I'll just grab parts of this. No count exists for the specified, or yeah, the specified count ID. And then if a count does exist, then return existing count. Great. So initially, you have count being either our count object that corresponds with the type that we created in our schema, or undefined. It could not exist. By doing this check here, throwing an error if one does not exist, and when existing count is undefined, then when we return it here, we are assured that existing count is an object. Great. Our last procedure is to update our count. Now there's technically two different updates. I'll just call it update count here, just so that we don't have two different procedures for incrementing and decrementing. But in order to control incrementing and decrementing, what I'm going to do is have an input here, z.object, and a user can pass in is increasing, and that will be a boolean, z.boolean. Great. And since it's a protected procedure, we're going to be grabbing it from user ID, so we don't need to provide a count ID. Great. Then after this input, we're going to do mutation. We're going to provide our asynchronous function here. Grab our context and our input. And arrow function. There we go. Let's plan out this procedure here. So let's just look at some of the ones that are back. So we can do the same check if a count exists for the current user. That makes sense. If it does not exist, then we throw an error. And instead of saying delete here, there's nothing to update. Then, if one does exist, we need to increment or decrement depending on the is increasing value, where if is in to do this, we're going to have to do await context.db.update count set, and we're going to provide only the value that we need to have changed, which is count. And based off of the is increasing variable here, we're going to do existing count dot count plus 1 or existing count dot count minus 1. So hopefully that's easy enough. And we need to tell it which count to do. So where equals count dot user ID context dot user dot ID. Wonderful. So going through this again, we check to see if a count exists for the current user. If it doesn't exist, we throw an error. If it does exist, then we increment or decrement based off of the user passing in a Boolean value, true or false, to is increasing. Wonderful. Okay, last step with the count router here as we go through and scroll through so that you can have a chance to copy anything if you've forgotten anything. We need to add our count router to the overall app router. So here we can just do count, provide a key to our count router, and we grab that from /count. Great. So when we create each of our routers, we just need to remember to add them to each of our individual routers. Great. So let me go into a quick discussion about some key concepts that are going to be needed. Then after that, we're going to jump straight into the demo.